Now I will explain the line emission spectrum of hydrogen. So it's important that if you don't know anything about this, about wavelengths, frequencies, emission spectrum, what is this prism doing here? This is the part 4 of this video, emission spectrum / electron configuration. I highly recommend you to watch part 1, part 2, and part 3, where I am explaining from scratch all of these terms. What is wavelength, what is frequency, how the speed of light is related, how energy is traveling, why is the name of electromagnetic radiation, and many things, okay, in the videos before part 1, part 2, and part 3. In this video, part 4, I will explain only from the emission spectrum of hydrogen. The thing is that if you don't know some terms that I will use here, is because you have to revise the previous videos. I will explain now. Here we have this hydrogen. As I mentioned before, this hydrogen is getting excited, so meaning that this gas is discharged, is in a discharge tube containing hydrogen, yes. So we pass through slits, then we have a prism that is dividing different wavelengths. So those are the wavelengths that we have here. I love this picture because illustrating exactly what I want to explain. So then we get this emission spectrum over here, and this one is the one that we have here, okay? As you see, hydrogen is only emitting in those particular wavelengths. So hydrogen is emitting in 656, 486, 434, and 410. Depending on the atom, depending on the gas that is discharged in the discharge tube, this gas will emit a different emission spectrum, okay? In that case, is hydrogen, but we can do this emission spectrum of helium, for example, and it will look different. It will look different. This is the fingerprint of hydrogen, okay? Here is just showing how, in this graph is showing how from energy level 1 is falling down to energy level 2, and this energy is being emitted, okay? Here we have the Planck constant, here, and here we have the frequency with a particular frequency, something that I talked before when I explained these equations. And yes, this is the emission spectrum of hydrogen. The emission spectrum of hydrogen is showing us here particular electrons are jumping and falling down to a specific energy level. This is an example of how we could see the hydrogen atom. Let's say, because hydrogen only have one electron. Here we are explaining different energy levels. Energy level 1, so the electron is here. Once this atom is excited, the electron is jumping to energy level, let's say 4. There is one moment when this electron is falling down. It's not falling down all the way to the first energy level. Let's say that this fall down only to energy level 2. Because it's falling down from a higher to a lower energy level, this atom is emitting, and this emission is quantified with a wavelength, and this is the one that we could see in the emission spectrum. It's excited and is jumping to energy level 5 over here. Atom emits energy by falling from energy level 5 to energy level 2. It's energy 5 to energy level 2, very similar to the one that I mentioned before. What happened if instead of falling down to energy 2, will fall down to energy 3, or it fell down to energy 4? And what happened is when it excited only get to energy level, this is what happened. There is a convergence here of the energy level. You need to understand that. If you see the distance between the first energy level and the second energy level is larger than the distance between the second and the third energy level, and it's even shorter when you get to the 3 to the 4th and 4 to the 5, you see that the energy levels are getting closer and closer and closer, meaning that this is a convergence of the energy. That's why we put infinite here. A lot of energy level will be very close from one another. And then in the shell, we will understand the ionization energy and how an electron is leaving the atom. But we will talk about this later. Once you understand that the energy is converging in here, in the higher energy level about the first four energy levels and the distance that we mentioned before. If an electron is jumping to the 3 energy level when it's excited and then is falling down to the energy level 2, is producing this red light, and it will be in the visible spectrum. What happens when the electron is jumping to energy 4 and then it falls down to energy level 2? That will be a different delta E. Do you remember the equation that we talked about, delta E? Here we have the equation. Delta E, energy of the photon. So different energy of the photon, different energy will produce different color as well. If the electron is falling down from energy level 4 to energy level 2, is emitting another color. From energy 5 is emitting another color, and here from 6 is not emitting any color because there is wavelength, a frequency that we cannot see, is not in the visible spectrum. If you don't understand this, and this is very different, I invite you to watch part 1, part 2, and part 3 because I am explaining from scratch what is all of this. But before starting on the other parts, that will be very easy for you to understand. Those are the excited states. The electron is falling down, and here we have the different colors on the visible light. So we are able to see these emissions of light. There is something when we study the electron configuration in the next part of the chapter, and I am explaining the different names of different falls down of different energies. Patchen, Barner, so there are different names of the different falls downs and different colors and different things, which will be very important and very interesting for you to know, and also because it can show that in a paper.